Ralph technique completed contract work that would have costed $50,000 through traditional outsourcing, just for 297 include API costs. During testing at Y Combinator, Ralph generated 6 completed repositories overnight while the team slept. Perhaps the most impressive demonstration, Ralph created an entire programming language called Cursed over 3 months of continuous iteration. Because of these reasons and these impressive results, Ralph Wiggum has gained popularity over the last couple months. So let's see what's unique about it. What most coding agents do, at the beginning of your session, you're going to have a context window. The context window is basically the place where we store the information, the data, the prompt that the agent or the LLM need to have access to in order to solve the problem. So this is the context that's going to be loaded directly to the large language model at the start. So at the beginning, we only have filled about 40% of the context window, and therefore the LLM still have some window of context to put their additional information, like for example, to load some files to the context. As the conversation basically grows, the context window is going to be filled with conversation messages, and therefore the quality will degrade. So it has been proven that whenever the context window gets closer to be full, the LLM generation quality degrades. That's why you need to open new, for example, tabs in ChatGPT, and that's why you want to start new sessions in Claude Code often. Then what happens when the context window is full? What happens is that Claude, for example, is going to tell you that the context window is low and there are no more tokens that can fit in the context window of the LLM. And it's going to tell you to compact or to summarize the current conversation in a new, fresh context window. It's going to take the current conversation, take all the context that we have so far in this context window, and it will try to basically summarize it and to compact it and put it in a fresh session or a fresh context window. The problem with this is that this summarized context obviously cannot hold all the context or all the information that we need to pass to the LLM to complete the task, right? So what might happen is that there might be some important information here that is not going to be included in the summary. And therefore, we're going to lose some information that is necessary to complete the task. And therefore, we're going to have like some issues or some bugs, or it might just like not have enough context to solve the problem. So to solve this issue, Ralph does something a little bit different. So at the beginning, you will have basically the product requirement document. So you would have all the information that is needed to complete the task. Like you will have the requirements, what you are implementing, what is the success criteria, also what are the features and sub features that needs to be implemented. So at the beginning, you define that. And then Ralph is going to divide the overall task into multiple tasks. And every task is going to have its own context window, as you see here. It doesn't like run sequentially and the context window keeps growing. What happens instead is that first it does some changes. It commits the changes after the acceptance criteria for that specific task is met. And then it puts the progress in the progress.md file. When we want to implement the second task, task B, what happens is that we read the progress.md file to know what files has been changed from the completion of task 1. What are the commits that has been added to the Git history. Also, given the requirements that are needed to complete task B, we put that in the context and we discard any information that has been exchanged during the completion of task 1 and we focus on completing task 2. What happens after that? The same. We commit the changes for task B. We update the progress.md file, and this happens only when we pass the acceptance criteria for task B. For task C, pretty much the same. So we look at the commit history, we read the progress.md file, we keep iterating until we finish the task, we report back to the progress, we report to the Git history, and we move to the next task until we complete the overall project. So when all the task has been completed, we guarantee that the overall project is also completed. So this is the idea of Ralph. So in practice, we will at the beginning have the product requirement document. So the product requirement document is going to look something like this. The task description, the project name, the description of the project, and the user stories. The user stories are basically the tasks that we want the agent to complete. So for example, for this story, we add priority field to the database, and the acceptance criteria is add priority column to the task table. So this needs to be done in order to mark the task as completed. Also, we generate and run the migration, and the type check should also pass. And by default, all the tasks at the beginning have not passed the tests yet. And now we run the ralph.sh file. So this is the bash file that runs the main loop. The main main idea of Ralph is that it runs the agent in a loop. In every iteration, we load the prompt and we give it to the coding agent. In this case, it's AMP, and we let the agent to run in the autonomous mode. So it's not going to ask us for any permissions to run any command. Then we report that, like we report the results in a file. When we complete the task, the agent is going to publish a complete phrase. This happens when all the tasks that we have in the PRD file are marked as complete. We run this loop. The first thing that happens is that first it's going to pick a story that needs to be done, and then we implement it. So it writes the code for it, it runs the tests for it, and then it commits the changes to the branch. And then after that, it's going to update the PRD JSON, like to set the pass to true, that okay, this user story, this task has been completed. Also, we log the progress to the progress.txt file. So basically it's going to learn from its mistakes, or it's going to discover patterns that's going to enable it to improve for the upcoming iterations. Okay, so now after it does that, it's gonna check, are there more stories? If there are more stories that have passes equals to false, it's gonna pick the next based on the priority, and then it's gonna try to implement it. And this loop basically keeps running until all the tasks get completed. And the promise is that after the end of this loop, your task will be 100% completed based on the success criteria that you specify. All of that depends on the context that you give it. Does it have all context to solve this problem? And also it depends on the definition of your success criteria and acceptance criteria. So if your acceptance criteria really guarantees that your task is completed, and if it's measurable, and if it's easy to check, for example, the type checks passes, there are multiple ways to verify that. Generate and run the migration. So it needs to verify that the migration has been generated and ran. You need to set a priority also carefully in such a way that tasks do not depend on each other in a circular manner. So you do not have a task that is higher priority that depends on a task that is lower priority. So you need also to keep that in mind. So that's the idea of it. Now you can actually go to the repository here. All you need to do is basically to follow the setup instructions. Here they tell you to do it with AMP. And then after that, you just define your feature description, and it's then just gonna run this loop for you until your task basically is completed. And also it's gonna generate the success criteria for you. You just need to verify it, to verify how it works. That was all I wanted to share with you. Thanks so much for watching. See you in the next one. Bye-bye.